Welcome back, Science 10s. For this video, we are going to be learning about distance time graphs. Now, an excellent thing about this PowerPoint presentation is if you go onto D2L and find the PowerPoint, you can print off the slides at the end, which will give you all the graphs that you're going to need for the activities we're going to do for this video. So if you want to do that first, pause now and go print off your graphs. Okay, so look at all these Simpsons people and remember everything that you can about them. 3, 2, 1, go! Now, tell me, which hand is Ned Flanders waving? How many balloons does Sideshow Bob have? What colors are they and how many of each? Which hand is Groundkeeper Willie's shovel in? What is Moe holding? And what color is Milhouse's shirt? See how many you can get right. How observant are you? The CIA wants to know this stuff. Are we ready to learn about distance time graphs? All right, he's never going to catch that turtle. All right, here's our first graph. We have some information that tells us Homer's motion. Our distance time graph is going to look with distance on the y-axis and time on the x-axis. In this case, we have distance traveled for meters and time taken is in minutes. We need to have labels with units here. We also need to have an appropriate scale. Now these scales are made for you, and if you printed them off, they'll have the scale already. But you do have to make a scale for your own distance time graphs. This is the trickiest part because it's easy to make it too small or too big and then you have to erase it. So you need to have a pencil when you do this. So figure out your distance that you need to put into the appropriate scale and the time taken in the appropriate scale. And then we have to figure out what's happening with the motion. Our first point, after work, the bell goes and Homer stops work and runs 250 meters to his car. This takes him 5 minutes. So I already pushed the button by accident, but you can see that my red line has gone from 0 to 250 meters in 5 minutes. Easy, right? The next one, Homer's going to drive for 10 minutes, but only gets 2,000 meters before he has to stop for a donut. However, that's a much faster rate of speed here. He's in his car instead of running. So he goes 2,000 meters. So we're at 2,200 meters now in 15 minutes. He then sits in his car and spends 5 minutes eating the donut. I feel that's an over-exaggeration. He could eat it faster than that. However, we're going to see a straight horizontal line because he's not moving anywhere. He's sitting in his car. So the distance time graph can tell us about Homer's position and his velocity. And then the last bit, he starts his engine and drives for 5 minutes 1,000 meters back home. So in 5 minutes, he goes another 1,000 meters. This is what his distance time graph looks like. And we can find out many things in here. We can think about the slope to find out velocity because that's meters over, well, this is minutes, it's usually seconds, right? We'd have to convert to seconds. We can also look at his position about where he's going, his distance. Let's try the next one. Here's Bart. Here's our distance time graph again. We have an appropriate scale. Remember, we can't just put the numbers we want on the scale. We have to do it in order. So it has to be the equal amount between each number. So 200, 400, 600, 800. We always have 200 meters in between each point. This is important. We can't have varying ones of 200, 500, 900. That is not allowed. It is illegal in graphing. Same with the time. You can't just put the time you want. You have to put them in order. Okay, so let's make the graph. We see that Bart sprints 100 meters through school, which takes 1 minute. That's a teeny tiny line. It's going over 1 minute and up to 100 meters. Then he jumps on a skateboard, and in 4 minutes, he goes 500 meters through a crowd of people. This looks like he is going faster. I see that the slope is steeper. He then jumps off at Apu's and looks around for 10 minutes. He's not going anywhere. He's in the store. He's in one place. So we see that at 600 meters, he is just stationary for 10 minutes. He then jumps back on his skateboard and travels 750 meters in 4 minutes. He's super fast. Look at how fast he is and how steep that line is. So this is his distance time graph of what he did. So it tells us the activity of Bart. Let's try Lisa. So here's Lisa. She sees the time and spends 5 minutes packing her saxophone away. She hasn't gone anywhere. We started the time, but she didn't move anywhere. Then it's a 5-minute walk to her bike 300 meters away. So in 5 minutes, she goes 300 meters. She then cycles on a flat 800 meters in 5 minutes. Now you may have thought that was going to be a flat line because they tried to trick you, but it's not. She was still moving 800 meters. It took her 5 minutes. Then she reaches a hill and slows down. She travels 300 meters in 3 minutes before reaching home. So she's going up a hill, which means she's going slower. And on this graph, we can see that because the slope is less. It is not as steep as the previous slope when she was cycling on flat ground where she could go faster. So this distance time graph tells us about the velocity. The slope is the speed or the velocity. Here's another one about Marge. So Marge has to go shopping. She's driving 1,500 meters in 10 minutes. So we see that the scale is quite different here, right? Look at it's much higher. It goes up all the way to 3,500 meters. So you have to adjust your scale for each distance time graph you make. We see that in 10 minutes it goes up 1,500 meters. She then realizes she might be late, so she speeds up and covers the next 1,000 meters in 2.5 minutes before reaching traffic lights. So she goes much faster. We can see the steepness of that slope. Now she waits at the light for 5 minutes. She's waiting there. She's not moving anywhere, so we will know that it will be a flat, horizontal line for 5 minutes. She then drives home 500 meters, and it takes 5 minutes. So there's the end of hers. So we can see her speed and her distance traveled and the time it takes her. So let's see if you can do this one. Take out your graph and look through the points and draw them. Pause here and do that. This is what it should look like. Did you end up with something that looked like this? If not, go back through the steps and see where you went wrong. The next one, sometimes we get a table that shows us the distance traveled and the time taken, and we have to make the graph from it. So we have to figure out this distance time graph, and we could figure out his velocity, his speed, for Bart. So here's his distance traveled and his time taken. Here's the graph that you need, and draw it using the time. We know that okay, so we see that Bart went in 8 seconds, he went 5 meters, and then continued to go faster and faster and faster. So we see his motion accelerated here. His velocity increased. Now here's the last slide. You need to try and figure out all these questions and show them to us tomorrow. So who's the first to reach the sofa? How long was Maggie's complete journey? Which Simpson reached the fastest speed? If Homer left 5 minutes early, would he beat the rest of the couch? Who's the closest to home after 5 minutes? You have to go back through all of the graphs that you did, try and figure out those questions. Good luck!